Okay, here we are, Unit 4, Lesson 1, Exponent Rules Review. So exponents give us a way of writing repeated multiplication. So if we had 4 to the exponent 5, it would mean 4 times itself 5 times. Or if I had -3 to the exponent 6, it would mean -3 times itself 6 times. It's a way to shorten some multiplication, so it gives us a shortcut. There are 5 exponent rules that make using exponents much easier to do. They shorten and give us shortcuts. The first exponent rule is the multiplication rule. So if I have something like 3 to the exponent 3 times 3 squared, 3 to the exponent 3 would mean 3 times 3 times 3 times 3 squared, which would mean 3 times 3. If we expanded it all out, I would have 3 times itself 3 times and 3 times itself 2 times multiplied together, which would mean all together I'm multiplying 3 5 times. Or if I had -2 to the exponent 2 times -2 to the exponent 4, I would have -2 times itself 2 times times -2 times itself 4 times. So that altogether I would have -2 times itself 6 times. When you multiply powers with the same base, like I did up above, there's a bit of a shortcut. 3 and 2 make 5, so that I don't have to actually expand it all out to see how many 3's I'm multiplying. Or 2 plus 4 makes 6, so I don't have to expand it all out to see, well, how many I'm multiplying. So when you're multiplying powers that have the same base, we can do that little shortcut. We keep the base the same and we add the exponents. So if I have any base with any exponent times any base with any exponent, my shortcut is I keep the same base and I add my exponents together. So I don't have to expand it all out. For example, write the following as a single power and evaluate where possible. So if I have 4 to the exponent 3 times 4 to the exponent 2, keep the same base, and I add my 2 exponents together. So I have 4 to the exponent 5. And then I get out my calculator, and I evaluate 4 to the exponent 5. 4 to the exponent 5 is 1,024. If we look at B, -3 to the exponent 5 times -3. Be careful, if there's no exponent down, it means there's still a 1 there because there's still 1 3. So I keep my base, the brackets are important, and I add my exponents. 5 plus 1 is 6. So I have -3 to the exponent 6, which is 729. If I look at a couple other examples, nothing changes when I have a fraction base. As long as the base is the same, the fraction is the same. I keep the base when I'm multiplying, and I add my exponents. So 2 plus 3 is 5. And the difference is when you have a fraction as a base, you need to do the exponent with the top number and do the exponent with the bottom number. So I have 2 to the exponent 5, which is 32. And I have 3 to the exponent 5, which is 243. So I get a fraction answer from a fraction base. Last one. If I have a variable or a letter, as long as the letter is all the same, when I'm multiplying, I keep the same letter and I add up all my exponents. So 3 plus 5 is 8, plus 4 is 12. So I have a to the exponent 12. And because I don't have a number for the base, that's it. I can't calculate an answer. So there's your first exponent rule review. When you're multiplying with the same base, keep the base, add the exponents, and then evaluate. Second exponent rule is the division rule. So if I'm dividing 3 to the exponent 6 divided by 3 squared would be 6 threes, 1, 2, 3, 4, 5, 6, divided by 2 threes. And so if you have the same thing on the top as you do on the bottom, you can cross it out. So for each 3 on the top, crosses out with a 3 on the bottom, which means I'm left with 4 threes being multiplied together. Or if I look at my other example, I have -2 times -2 7 times. What am I on? 2, 3, 4, 5, 6, 7. And I divide by -2 to the exponent 4, which would be -2 4 times. And when I have the same thing on the top as I do on the bottom, I cross it out, which leaves me with -2 to the exponent 3. If I look at these two questions, the 6 and the 2 relate to the 4 because 6 take away 2 is 4. If I look at these two exponents, the 7 and the 4 relate to the 3 because 7 take away 4 is 3. So just like with the multiplying, there's a shortcut for the division rule. If you think about it, it kind of makes sense. Multiplication rule, you kept the base and you added the exponents. Division is kind of the opposite of multiplication. You're going to keep the base and you subtract the exponents. So whenever you have the same base, keep the base the same and subtract the exponents. So no matter what the base is, as long as it's the same, you can subtract the exponents for a shortcut. So if I look at a couple of examples, no matter what the base is, as long as the base is the same in the question, 4 to the exponent 3 divided by 4 to the exponent 2, I can write it as a single power by keeping the base and subtracting the exponents when I'm dividing. So 3 take away 2 is 1, and 4 to the exponent of 1 is just 4. Or if I look at B, I've got the same base. Remember that little trick, if there's no exponent written down, there's an exponent of 1. So I have -3, 5 take away 1 would give me an exponent of 4, and -3 to the exponent 4 would be 81. Last one, fraction again. It's okay to have a fraction base as long as the two bases are the same. I'm going to keep the fraction, and I'm going to subtract my exponents. So 4 take away 2 would be 2. And then just be careful with a fraction. You want to put the exponent with both the top number and the bottom number. So 2 squared is 4, and 3 squared is 9. So my answer is 4/9. And last one, you can do the same thing. Use exponent rules with variables as long as the letter is the same. Keep the letter and subtract all your exponents. Remember, same deal as above. If there's no exponent, there's still a 1 there. So I have 5, take away 2 is 3, take away 1 is 2. So I have a to the exponent 2 when I use my exponent rule. So multiplication rule, multiplying with the same base, keep the base, add the exponents. Division rule, dividing with the same base, keep the base and subtract the exponents. Third one, power to a power rule. If we have a power to a power, 3 squared to the exponent 3 would mean I have 3 squared times 3 squared times 3 squared. 3 squareds 3 times. And then each 3 squared is 2 3's. So then each 3 squared means 3 times 3. So for a grand total, I would be multiplying 3 times itself 6 times. Or if I look at this one, negative 2 squared times negative 2 squared. 2 negative 2 squareds. And then each negative 2 squared is 2 negative 2's. So I have a grand total of 4 negative 2's that I'm multiplying together. If we're looking for a shortcut, 3 and the 2 relate to the 6 because 3 times 2 is 6. And the 2 and the 2 relate to the 4 because 2 times 2 is 4. So the power rule, when you have a power to another power, which means you have only one base and two exponents, keep the base the same, just like with all the other rules, but this time you multiply your exponents. So if I look at a couple of examples, power to a power. I have 3 to the exponent 2 to another exponent. 2 powers, 2 exponents. My shortcut, keep the base the same and multiply the exponents. So 2 times 4 is 8. And then 3 to the exponent 8 would be a large number. There we go, 6,561. Or for this one, negative 4 is exponent 2 to the exponent 2. One base and two exponents. Keep the base. Make sure you keep the base and multiply your exponents. Negative 4 to the exponent 4 is 256. All right, last two. Careful when you're doing the power rule, when there's more than one piece inside the bracket. Each of these pieces has the exponent. The y has an exponent of 4, and negative 2 has an exponent of 1 that we're too lazy to write down. So when you're multiplying exponents, you have to make sure you multiply all the exponents in the bracket. So that would mean I would have negative 2 to the exponent 5 and y to the exponent 20. And negative 2 to the exponent 5 would be negative 32, and the y to the 20 would stay the same. Multiply all the exponents. And if you have a fraction, no worries. Same deal, one base, two exponents. Multiply your exponents together. Don't worry about the negative signs. Just use your integer rules. So negative 2 times negative 1, two negatives make that a positive. And then like we were talking about before, 1 to the exponent 2 is 1, and 2 to the exponent 2 is 4. Do your exponents. So multiplication rule, division rule, power rule. The three basic exponent rules. One thing that's really important when you go to use those rules to simplify. Oh, that's not going to work. When doing problems involving power of a power rule, you want to do the power rule first. Do the power rule first and multiplication and division rules last if there's several options. So if there's a power rule and multiplication and division, do the power rule first, then do your multiplication and division rules last. All right. Good luck with your questions. Let me know if you have any problems.